Introduction to exercise 9.9 on applying logarithmic functions on page 427 of your textbook. It is really just the Newton's method and then your worded application style questions for integration, and then that's pretty much it for the entire chapter. This is the last exercise for the term. So revision of Newton's method, quick notes, refresher, x of n plus 1, or rather xn plus 1, equals xn minus f of xn over f dash of xn. Basically, we're using Newton's method, which is an approximation of a zero. In other words, we're looking for a solution for x. Right? If I give you, for example, a cubic, if I want to try and find the values of x that is not a very nice number, you can use Newton's method to approximate it. Every time you use more iterations, x1 would be a first iteration, x2, etc., then it will become more and more accurate. It is one, as math teachers, we identified that being I will most likely use for pseudocode as well. But this is the approach. Okay, so we have the next value of x equals to the previous value of x minus the function of substituting the value of x divided by the derivative function of substituting the value of x. In this example, it says use Newton's method to approximate a zero for y equals to ln of 2x minus 1. If x0 equals to 2, find x1. So we're saying the first iteration would be x1, but we're starting off with x0 equals 2. So apply my formula, I know that x, or in this case 1, equals to x1 equals to the function substituting our value of x0, which is 2. So we'd end up with ln of 2 times 2 is 4 minus 1 is 3 over, and I'm going to find the derivative, right? So let's find the derivative separately. I'm just going to do that over here. So if I write, for example, dy dx, okay, dy dx, of course, we end up with 2 over 2x minus 1, right? So it's going to be 1 over 2x minus 1 and then multiplied by the coefficient or the derivative of the internal function, so 2 over 2x minus 1. Okay, yes?
For x1, isn't it supposed to be 2 minus?
So we're going to continue and we're going to put that in there. Thank you very much. Substituting my value, I know that dy dx, which in this case I'm just going to write let's dy dx equal to f dash x. A quick reminder, it does give me y equals, so I can't suddenly drop an f dash of x or f of x without a definition. Okay, so let equal that. Let dy dx equal to f dash of x, which then would equal to, and I'm going to actually substitute f dash of x 0, or in other words 2, which give us 2 over, and it's 4 minus 1, so 2 over 3. Now we can go back to our original function, our original equation, sorry. We know it's 2 over 3, so substituting that back in is saying that 2 minus ln of 3 over 2 over 3. Of course, I know that then f for x1 equals to 2 minus, and because I'm going a numerator divided by a fraction, I'm going to take the top 2, which gives us 3 ln of 3 divided by the bottom, the middle 2, sorry, which would just be 2. Then, of course, you can just put in the calculator. Newton's method is one that will most likely come up in exam 2, given the fact that if it says using Newton's method, you have to use it, which means that you can get to this very last stage and then use a calculator. Okay? But just as giving you a heads up, it'll most likely come up in exam 2, or as an exact value in exam 1. But that will suffice. Any questions? Okay. Let's move on to example 2. It says the number of words learned can be modeled by the equation W. Now, just to be clear, this is not a legitimate thing, but in this scenario, it can be modeled by the equation W equals to 109 natural log of t minus 2 plus 150 for where t is greater than or equal to 3. How long does it take to learn 600 words? Again, I will erase this side and then I'll write questions B and C, but in the meantime, we'll focus on this one. To learn 600 words, of course, we let W equal to 600. Now, I just want to be clear, it seems very obvious to us, especially if we know what we're doing, to say that, well, obviously, if 600 words, we just replace W with 600, right? But in the exam or in the assessment, make it very clear. Let W equal 600. Make it very clear, which you can then there write 109 ln of t minus 2 plus 150. Easy. Let's do that transposition. So I'm going to minus 150 on both sides, which gives us 450, and then I'm going to divide by 109. Hopefully I'm not going too quickly. Looks like I'm not going quickly enough. I'm going to rearrange that to get e as a base, right? And the reason I know that that's the next step is because there's no other transformations, no other plus whatever on the other side. So I'm just going to go ahead and do that. I'm going to go e to the power of, it's a weird e to the power of 450 over 109 equals to t minus 2, which means, actually I don't need a comma there, I'm just going to write an arrow, which means that and with t equals to e to the power of 450 over 109 plus 2. That's a big 2. Is it the handwriting that's a bit bad? Is it legible? Approximating this again gives you about 64, but that's an unnecessary step. This should be expectable to be done without a calculator, not that part. Everything else but that, approximately 64. Are we okay for me to erase the left-hand side? All right. What's my other hand? There it is. Second component of this question, we're focusing on find an expression for the rate of learning. And then there's a third component, but we'll get to that in a moment. So find an expression for the rate of learning, pretty straightforward. All we need to do is find the derivative. Okay? So we have, and I'm just going to rewrite that from over there. W equals to 109 ln of t minus 2 plus 150 to find the derivative dw dt. Another quick note. In this case, and I know it's not very clear, but I have written capital W over here. A mistake that some students make is to say, well, it's capital W, right, dw dt doesn't really matter, right? Please make it very clear in your actual assessment. If it's capital A, you're using capital A, right? You shouldn't be redefining it as log SA without. Well, actually, you can redefine it, just make it clear. Don't just randomly write it. Good. Which means it gives us 109 multiplied by 1 over t minus 2, so 109 over t minus 2. It is expected, right? It is expected that if you're doing this question, you do not need this step. This is just for me to make this very clear, scaffolder for you. But if you're doing this, whether it's exam 1, exam 2, this should suffice to jump from dw dt equals to that. That's fine. Are we okay for me to erase a third, so first A? Okay. How long before the rate of learning is down to one word? It should be per day or per t, but you get the understanding. This is pretty much, again, just application of what we already know. Again, just to make it very clear to the assessor, let dw over dt equal to 1, right? Instead of just equating it to 1, just make it clear. That means 109 over t minus 2 equals to 1. 109 equals to t minus 2, and on both sides, t equals to 111. Now, I haven't specified in the question, but it should be days. So I'd write 111 days, but that's it. So again, just stuff that we already are familiar with. Any questions?